A little bit of the keynote, Morten mentioned this thing called APL Sharp. Now, we've mentioned it on and off over the past few years, but we haven't really got into much detail about it, other than saying, Jonathan's working on this stuff, it's very cool, it's very interesting, but we haven't actually stood up and said very much about it. And that's mainly because it's taking longer than we thought it would do. We started the project quite a while ago, and it turns out language design is actually quite hard. So I just want to start by apologising for the lack of information. It's not because we're not working hard, we are. It's just that these things are very hard to predict and taking longer than they should do. So for those of you who we've promised more information by now to, I apologise. For the information that I promise we'll be delivering over the next year that we failed to deliver, I apologise, but we will get there. So, today I'm just going to be talking about where we are in the project, a few language design things, just to give you a flavour of how we're getting on and where we're at. So, first of all, what is APL Sharp? Now, the thing at the top says lightweight APL engine. What's that? Well, Dyalog. This is going to sound bad, but I'll call it a heavyweight APL engine. Sorry, John. But by a lightweight APL engine, I mean something that just does the APL. So it can do 1 plus 2, 2, 3, 4, but it can't do GUIs. Just does APL. So Dyalog does GUIs and knows lots about sockets and all sorts of other good stuff. So that's bigger. And heavier. So APL Sharp will be a lightweight, fast APL engine. The second one, target systems where tight integration with the platform is required. Now, things like .NET, a phone, Windows RT, which I'll come to later, it's probably a new term that most of you won't have heard of. The platform provides a huge amount of stuff that the developer can use. So that these platforms all provide GUI and sockets and stuff, so the APL engine doesn't need to. And a lot of these platforms also provide mechanisms for many different languages to call the stuff and to talk to each other in a nice, lightweight, fast manner. So what you tend to see on these, built on these platforms quite often, is systems composed of lots of different areas. So someone might use C# and WPF for the GUI front end, but want to use something else for the business logic, which oftentimes APL is ideal for. So on platforms like .NET, Java Virtual Machine to some extent, and a few others, WinRT, by having a lightweight engine that can play nicely with everyone else and have very low overhead in the communication and transferring data between the various parts, we can write we can have APL living in systems where it's not centered around APL, whereas with traditional APL systems and traditional dialog development, usually the bulk of the application or the meat of the application would be written in Dyalog, and other things might talk to it and it might talk out, but 90-odd% of the processing of the system is all done inside APL. So Dyalog is still, if that's the sort of application you've got, the best place to do that. APL Sharp won't ever replace that. It's designed to work more where you've got a variety of things working together. So this is a bit vague and nebulous, but just trying to give you a flavour of the differences for now. So, yeah, APL Sharp, initially we're designing it mainly to run in places where Dyalog doesn't run, because we've already got Dyalog running in the other places. So, a fully APL .NET, not .NET based desktop application, so just a standard GUI application. Dyalog is probably going to be the best place to do that for quite a long time because it's already very good there. So, a few box diagrams now. I apologise for the box diagrams. I was at the Microsoft conference a couple of weeks ago, and it's not quite all got out of my head yet, so I seem to think that every presentation needs box diagrams. So. Anyway, those of you who've seen Microsoft presentations will know what I'm talking about. So, on Windows, the Windows architecture is there's a core thing that they call the kernel, which provides lots of stuff like file I/O, some really low-level stuff. And then they've got this thing called Win32 on the top. Now, all traditional Windows development, you have Dyalog or C++, just talk straight to the Win32, which talks to the Windows stuff, which does real operations on the disk. So it's fast and it's direct. But with the fast and direct access, you have a few more things that we as APL vendors have to take care of, or you as a C++ programmer would have to take care of if you were fool enough to write in C++. Whereas on the Microsoft.NET framework, Microsoft give an extra layer which adds lots and lots of utilities and functionality to make the programming language vendor, our job, a lot easier, and allow the programs written in different things to talk to each other. So because this is, particularly the different programs talking to each other is very useful, in Dyalog we have Bridge, which lets us call across into .NET and be called from .NET. But APL Sharp will be sitting directly on top of .NET rather than just sort of calling over the bridge. So we won't need a bridge. The interoperability mechanism won't be as heavy, so it will be faster. And down here, there's a similar but much smaller diagram for Linux. Linux has this thing called Mono, which is basically a copy of .NET. So you can write APL Sharp and C# programs that talk to each other on Linux as well. When I say you can write APL Sharp programs that run on there, you will be able to write APL Sharp programs fairly soon now, but when it's ready. So we also are going to support Silverlight, and Silverlight runs on a number of different devices and platforms. Again, there's a Linux version called Moonlight. John Daintree already showed a Silverlight application running on Windows and Mac OS, and because APL Sharp will run inside of Silverlight, we'll be able to write APL programs that also work on Mac OS and Windows. And I don't know how many of you have seen the Windows Phone 7, the new version of the Windows Phone. That is also based on Silverlight, and we will have an interpreter running in there as well if you need it. Now, I mentioned WinRT. This is new. This is so new that Microsoft only announced it at the conference I was at 3 weeks ago. So this is a new unmanaged, which makes it fast, platform for writing Windows code, and in particular writing stuff for Windows Metro. Now, Windows Metro is the new fancy touch interface for these tablet things that Microsoft were giving out, that's going to be coming with Windows 8. If that boots up, that's not even beta software yet, so sometimes it doesn't. But and it's Windows. So assuming this works, I'll give you a quick flavour. Yeah, it looks like it's going right. You've got sort of much more phone type interface. Now, I know you can't see this very well from the back, so if you want to have a look at this device or talk to me a bit more about this stuff, then come and find me afterwards. It's all about applications that take over the whole screen, whole device, so a lot more like phone type applications would. Rather than desktop applications that we're used to on Windows machines that all interact and all share the same desktop area. So That's a new user interface paradigm that's going to be coming with Windows 8. No one knows exactly when it will ship. The most that Microsoft would tell us was when it was ready, which I think is good, because APL Sharp will also ship when it's ready. Although I suspect Microsoft may get there first, so we'll see. But anyway, so APL Sharp will be running on WinRT. In fact, this was I only got this device, like I say, a couple of weeks ago. But APL Sharp, as it is already running on this device, which I'll try and show you later. So, APL Sharp and Dyalog. APL Sharp is not a replacement for Dyalog, and as Morten said, we are intending to invest heavily in both products going forward. And they are very complementary. They work better together because APL Sharp gives us access to different platforms that Dyalog doesn't, but Dyalog gives us many years of heavily optimized APL interpreter. So if you want to do a lot of heavy-duty APL work, Dyalog is the thing. If you want to work on platforms that Dyalog can't reach, APL Sharp is going to be the thing. So for the foreseeable future, which is at least the next 50 years, then APL Sharp and Dyalog will continue to coexist. So we're going to be sharing tooling. So things like the RIDE and the component server, you already saw the RIDE, will work just as well with Dyalog and APL Sharp. And more, as APL Sharp becomes feature complete, we'll be looking at ways that we can use all of the existing stuff with APL Sharp, and anything new tool-wise that we're looking at where it makes sense, we'll make sure that it runs on both platforms. So, yeah, this is what's happened over the last 12 months and why you haven't seen a lot of progress. Where's Carlo? Oh, there, yeah. In Berlin, we stood up and we said, look, this is what we're doing here. Isn't this wonderful? And a few people nodded. And Carlo didn't nod. No. He didn't even shake his head a little bit. He buried his head in his hand. And there was one thing in particular, that we were going to put reference arrays in as the main type of array. Now, it sounded good to us, and it sounded good because it makes a bunch of stuff with interacting with .NET just easier and more natural. The problem was, it turned out it broke a few things in APL in terms of ease of just using APL as a language. And Carlo was right, as I'm sure he will tell you he always is. Carlo was right, and we were wrong. And so we had to go back to the whiteboard, and we had to fix those issues. So because we presented a little bit, and it's not just Carlo, I'm picking on him, because you guys have been giving us feedback about the small amount we have presented, we've had to go back and do more work, but the net result is we are ending up with a much better language. So I'm going to go into a few details about the language shortly. As I'm going through those, if there's anything that you see that you don't like the look of, it doesn't feel right, or you think could be better, or you have any good ideas, then please feed them back to us, because we are listening, and it will improve the project, and it will improve the language. And after we ship version 1, it will be a lot harder to change things. Now, we haven't got any users, which is brilliant for me, because it means I can change things. It's great. So now is the time to give us feedback. Anything that, don't assume that we know what we're talking about. We usually get it right. I mean, to be fair, we're not completely daft. We've got John and we've got Roger and years of experience of language design, but we're not always right. So we want to make this a really good APL system for the community, and to last a long time. So any community feedback is more than welcome. And if we are going quiet and you're wondering what we're doing, please contact us on aplsharp@dialog.com, and we'll talk to you and give you updates. Okay? So yeah, we now feel a lot more comfortable with the language specification. We have a lot of blood on the floor. That's good. The language is getting more and more like a traditional APL every day, but still able to work on the new environment smoothly. This is good. And the old implementation, which the old interpreter that was running this time last year, has been thrown away and completely rebuilt. And yeah, that was good, but it slowed us down. So okay, on to some of the language details. So I'll be watching Carlo as we go through this. So APL Sharp scripts, we're going to be using scripts, which are just Unicode strings, usually stored in Unicode text files. There's not going to be a classic mode. It's Unicode all the way with this. And we're using scripts rather than workspaces, so to keep the data and the code separate and therefore easier to manage and easier to maintain. And it makes using the code a lot easier with tools which are working with multiple languages at the same time, like Visual Studio. If you wanted to use that because you had a project that was 80% C# and 20% APL, you'd probably want to have your code visible in both at the same time. Now, I'm not promising Visual Studio support early, but we want to make sure that we don't make that hard down the road. So, APL Sharp scripts, it looks like APL because it is APL, it's just strings and we're separating the workspaces out. Now, APL Sharp programs work on a few different types of things. First of all, we have arrays, which are now classic APL arrays like we all know and love. We have kept reference arrays, but we've made it hard to create them, as in you have to be explicit. You'll never get one by accident and not realize it. So we have kept them because the reason that we put them in the first place to work with data binding in .NET and things like that is still a valid requirement. And then we have a bunch of simple scalar types and spaces. I'll go through all of these in detail in a minute. Now, what I'm describing here is the core APL Sharp language, which will be present on any platform. On, say, .NET, .NET has hundreds and hundreds of different types, and they will just appear as simple scalars in general. And so all the types from the platform will appear, but what I'm talking about now is just the core of the language. Okay? Procedures are functions and operators, nil-adds. I'll go through those in a minute. So these are all the moving parts of the language, if you like. Okay, thanks to Carlo's wonderful input, arrays are just like arrays that we're all used to. There's nothing particularly exciting or interesting here. There's a few of these diagrams, I'll just explain what those are. For the type of thing called an array, it will have these properties, these members. It will have a shape, in this case it's a 2x2. It'll have a vector of items, which is the ravel order of the elements of the array. And it'll have a typical item, sometimes a prototypical item.
I don't think you mean to infer, it will infer the fourth element of that array. 1, 2, 3.
Oh yeah, so no, the things on the left are examples. No, the things on the left are examples, and this is a specific example. In this case, they were a bit close, and that really should have had a 4 on the end. So I apologise. Okay, numbers are numbers. They're as you would expect. Now, initially we're just putting normal floating point numbers and integers in. We're not putting rationals or any of the new numeric types that Dyalog has just learnt about, because we will get these working first. If there's demand for it, we'll bring the clever numeric types like rationals that Roger's working on for Dyalog. We'll move that code across and have them in in APL Sharp as well. Particularly rationalise would be very nice. Characters, character constants, single character constants, vectors of characters, exactly the same as you used to. They're Unicode character strings. But we're also introducing a new scalar type for text called the string. So anything within double quotes is atomic. And yeah, I haven't got any examples, but if you wanted to escape a double quote, just like in a character constant where you do quote quote, means quote within the string, but within the character constant, if you do double quote next to each other, you get a double quote character in your string. So strings are scalars. They're atomic. Sorry? Yeah.
So that example there is project. Sorry, I didn't notice that.
This one. No, my slide reviewer has
The middle one.
This one.
The middle one should have double quotes appearing.
No, there's a space there. That's a space. Some spaces are harder to see than others. So next year I'll colour all the spaces in different colours, and then we'll be able to see them. So yes. Okay, space. This is sort of a new concept, sort of not, but it's mainly a new syntax. Spaces are just containers for names, which is very like a namespace in Dyalog. So why didn't we just call them namespaces? Well, there are a few differences. For one, the only major difference between an APL Sharp space and a Dyalog namespace is that Dyalog namespaces know about the place where they were created. So you end up with a hierarchy of namespaces, which has advantages in that you can dot up and down them, but can also be a bit awkward. So for now, at least, we're working with the space does not know anything about the parent, the scope that it was created in. So there is no hierarchy implied. You can create a hierarchy with them if you want. That's quite easy. I'll show you how to do that if you talk to me later. But the main thing is we're introducing this new syntax, which is double brackets. Start a double bracket, write some APL Sharp code, close the double bracket, and what you're doing there is declaring a new space. And in that space, you're running all of these lines of code. So that there is declaring a space with X assigned to the number 10 and Y assigned to the number 20. So you'll see that syntax in a few more of the slides later on.
Can I give that a name?
Sorry?
Can I assign that?
Yes. Yes, you can name.
Build an array of them?
Yep. You can name spaces. Spaces are scalars in themselves, so you can do anything you can with a number. So Carlo's looking interested. Okay. Right, Carlo, look at this slide. We've got lots of glyphs. You know about these. These are just going to work the same as Dyalog. So this is just concentrate on this one and ignore that last one.
I mean that's the syntax is also optional.
Yes, this syntax is actually entirely optional. You don't have to use it. There are other ways. There are other ways of creating spaces as well.
John, just a sec. Could you get back to the previous?
To this one?
Yeah. In that object, space,
Yeah.
you have two strings to be executed at some time. Or you have two values, one 10 and the other one 20.
In this example, these are values. These are executed immediately. But there is a way of creating a new space from a string that you execute, if you want to do that.
What exactly the time those two sentences are going to be executed?
I think, Jonathan, the one thing you should have mentioned before this was that APL Sharp allows multi-line execution.
Yes, although it's
Because
yes.
This is surprising.
Okay.
You know, is this a declaration or is that actually an executable statement?
Okay. Well, this is a complete APL Sharp script. Now, APL Sharp. There's a couple more examples of this coming up later, but allows structures that span more than one line. And the space declaration is an example of that. So, yeah.
Actually, the question is execution of those two lines. It will be upon definition or upon reference.
Upon definition. So, yeah. So this is all of the lines in here are run as soon as that piece of code is arrived at by the interpreter. So we have primitives. We have lots of primitives. Now, I will just mention there is a version of APL Sharp on your memory sticks, which I'll come to in a minute. It's not got quite all the language features, but it has got a lot of primitives. But it's not quite as fast as Dyalog yet. Sorry? Yeah?
Sorry, I didn't mean to
No,
interrupt.
that's okay.
Are you trying to design an APL for the existing APL community, or are you trying to design an APL that's going to appeal to the masses?
Yes. Both.
That's the answer you need. And Morten and I have had this conversation. I'd love to get into it tonight in the speakeasy.
I'm not getting
You
into
have to
it.
get rid of that, what we're looking at right now.
Yeah, that's a conversation for later.
It has to go to all ASCII or...
You see Carlo about that.
Yeah, I'll see you both in the speakeasy tonight, okay? And then, yeah, I'll just put you on the same table.
Talk to you about it. That's got to go.
No, it is. The idea that the glyphs are a problem for getting APL adopted by people who don't already know it is a well-argued and definitely has some merits. I can't say I'm completely convinced that we need to get rid of them. I actually think they add quite a lot of value to the language. That's my personal opinion. And APL Sharp will definitely keep using glyphs. But we will, if we find there is a real demand or need from non-APLers as opposed to a demand that we think some APLers have, then we'll look at
I think it's true, is it not, that APL Sharp, unlike Dyalog, allows the naming of absolutely any
Yes.
parts
Yeah, you
of the
can.
language. So we could provide simply a namespace or a library which provides names for absolutely every piece of the syntax.
Yeah. So there are ways of hiding the glyphs if that becomes
I
required.
wasn't so much talking about, names or substituting names, but I guess what I really wanted to say was that you need to have an option, an ASCII option.
Yeah, it's a good point.
And not names, but we'll talk about it.
Yeah. That's definitely one for drinks. So anyway, yeah. As I was saying, it's not. It already does support most of these, but they're not as fast as Dyalog. And one of the main reasons for that is a lot of the implementation of these is actually written in APL Sharp. So we took a few of them, like plus and minus times divide, and implemented them in the interpreter. But then a lot of the more interesting ones, like domino, grade up, grade down, things like that, are actually written in APL. But not only are they written in APL, which shouldn't be a major performance problem, but they're written using such a small subset of the language that we really have handicapped ourselves in performance. And the reason we did that now is we gain a lot in flexibility. And we can get a lot of more primitives into the development chain quickly so that we can actually play with realistic examples using the code. So the version on your sticks, don't expect it to be fast. We know it isn't. We're not actually designing for speed yet. We're still working out the details of the language. So. Okay, moving on. Parentheses. This side is exactly as you would expect from Dyalog. You can put parentheses around things to sort out evaluation order. You can put parentheses around functions or operators, and the parentheses just disappear. But here, we've got something new. You can't do this in Dyalog. Put a parentheses around a multi-line expression, well, an expression list, as we call it. So what happens is that everything inside the parentheses is evaluated as if it was a separate script. So A is assigned to 10, B 20, and then A plus B, the value from the last expression, is returned outside the parentheses. So 30 to 40, yeah. And the variables that were the names that were created up here are available outside of the parentheses. Okay, unlike Dyalog, if you're doing stranded naming, you have to parenthesize the strands. So in Dyalog, the second line would set A to 4, B to 5, and C to 6. But in APL Sharp, the C is assigned to 4, 5, 6. The whole array goes. Oh, I've got a vote for yes, not a vote for off with his head. This is good. This is going well.
Is it a syntax error though?
Sorry, no.
Syntax error?
No, it's not, because all the names are valid. Because A, B, and C, if A, B, and C weren't assigned, you get a value error.
So the result of that, the second expression is 1, 2, and
Nested 4.
4, 5, 6 nested.
Yeah, correct. I've got one positive vote. I'm moving on. Okay.
Can somebody, what is the definition of APL 2? It is this one. APL 2 would not give us syntax.
They would do the same.
So,
Okay. So, square bracket indexing is exactly like Dyalog. There really isn't anything more to say about it, other than APL Sharp will have it. It's just like Dyalog. Now, one of the biggest things that that we spent time on is trying to consolidate traditional function definitions and defuns in Dyalog, because it seemed daft to have two different ways of writing functions when it's just one concept, it's one thing. So John talked at great length about this, John Scholes, in Berlin last year. And the paper is available from that conference if you want to get into more details on this. I'm just going to give it a very quick overview. It's not changed a lot since then. But basically, the function definition syntax is an extended version of Dyalog defuns. So it starts with a curly brace, has an optional header, has some lines, some expressions of the body of the function, and then ends with a curly brace. So we'll go through some examples of different types of functions. So a nilad, which is a function procedure that doesn't take any argument and returns a value. A nilad is declared by the header dot right arrow. Now, some of you may be wondering, hang on, isn't that go to? Well, no, we're not using the right arrow for jump. We have to use control structures for branching and controlling the way through programs. So the right arrow was free, so we used it for the header instead. So the dot says this isn't going to take any arguments on the left or the right, and it's going to return a value, in this case x, which is picked from above. Now the first line, the A, because the procedure that you've written doesn't take any arguments, there's nothing stopping it running. So it runs. As soon as it's declared, it's run, and the result is assigned to A, which is fine, but often not very useful. So the little backtick, the escape character, means don't actually run this thing just yet, because I want to do something with it as a procedure. In this case, I want to name it. So A, B, both return 10, but if you give a new value to x in the environment and run that again, then the A, because that expression was run immediately, is still 10. But because you've actually named the procedure here, this gets evaluated at this point and returns 20, which is the current value of x. I'm not sure if I explained that very clearly. If not, catch me afterwards. I'll go through it.
So at the bottom line there is A a function or a scalar?
A is a scalar number, and B is a function. Well, a procedure, nilad. There was a bit of debate in the office about whether a function that doesn't take any arguments is actually a function, and there are very good reasons for saying it isn't. So we call them nil-ads instead. It's a name. Okay, functions. Just like defs. Only, so the top, almost just like defs. There are a few differences which I'll get into in a minute, but since, in terms of how you declare them, they are very like defs. So, but they can have an optional header, so you can name the arguments in the header. So in this case, AB maps to A plus B.
So that means we were missing 20.
No, I'm sure I had 20 in there earlier.
Yeah.
It's, oh, there it is, found it. sorry about that. I'll glue that back in later. And in this case, we have the right argument is named, and it's named as a strand. So named arguments can either be a single name or a strand of names. And effectively what happens, before the body of the function is run, when you come into the function, alpha is assigned to the named right argument. And so in this case, A, you can imagine there's a line here where it says A gets alpha and B gets omega, just in here before we run that. So even if you've named the arguments, alpha and omega are still available, and they're the entirety of the left and the right arguments. Apart from if you call the function monadically, so you don't actually supply a left argument, in which case alpha is given the default value of the right function, which means that you can write an expression like this to figure out, to provide a default value for the left argument to your function. Rather than the slightly odd syntax which we have in Dyalog, where you would just say alpha gets 21. But you look at that and you can't, it's not blindingly intuitive that you're not always doing that. You're only doing that if alpha isn't run. That doesn't already exist. Sorry. Okay. Monadic operators. Again, like Dyalog, you're defining the derived function. Unlike Dyalog, you have to provide a header for operators, unlike different operators. And the operands go between braces in the header. So in this case, we're producing a monadic operator that has two arguments and takes one operand and does the bit underneath. I don't want to run into the coffee break, so I'll move on quickly. Dyadic operators are very similar. And like I say, John did a good hour's talk on this last year, so I'm going through it quickly. If you've got any more questions, come and find us, or if you want to read up on the talk you did, last year's paper is good. So, declaring spaces. The top line, we have an array of 3 different spaces. And just like namespaces, you can dot into them to get to members. Unlike in Dyalog, we can also escape the dot because arrays have properties. Arrays have interesting things that they know about. So an array knows its own shape, and it has this thing called shape. Now, why would you want to do that when we've got row is a perfectly good way of, or row, sorry, is a perfectly good way of finding shape, and row is a good way of finding the rec. You don't need that. But if we're working with other languages that don't know about row as a primitive concept, they may want to take an array and figure out, oh, what shape is it? What are its dimensions? So we provide these named properties for some of the objects in the system. And if we're providing them for interop with other languages on platforms, then we sure as heck ought to have a way of getting to them from inside APL. So that's all this little escaped dot is doing. I should say at this point, on your memory stick, as well as some of the other talks and things, there's a couple of documents in the APL Sharp directory. One of them goes into this in a lot more detail. So I'm just a bit short on time, so I've got to rattle through. We're going to support guards, which we do in Dyalog defense, and they're exactly the same. And we support control structures just like in traditional functions. And unlike Dyalog, you can mix and match guard and control structures within the same function. Personally, I use that for checking my arguments on the top of the function. I'll use guards, and then for control flow, for say going across an array, if I didn't want to use each for some reason, I would use a loop or various other control structures. Right, back to some more wordy slides. That was the language overview. If you've got any questions about that, do see us. This whole thing is still developing, but the core of the language does seem to be becoming a lot more stable now, which is good. It means we've probably got most of it right. But if there's anything you saw that you think we haven't, let us know. Because getting it right is still more important than getting it out and shipping it. It's very important for us to get this language right, because we're expecting it to be successful, and therefore any mistakes that we make now in the language, anyone who uses it will have to live with those for the next 20, 30 years. But having said that, if you want to work on one of those platforms and Dyalog can't support what you're trying to do, then please let us know, because if we've got some real projects, that will help speed up the development and focus the areas that we're working on in the shorter term. Okay, I probably ought to show you a very quick demo, which come out of PowerPoint. On your memory stick, there is a HTML page and a .xap file, which is the current embryonic version of the interpreter. If you load up the HTML page and you've got Silverlight, an up-to-date Silverlight installed on your machine, you should see a screen like that. If you try it and you don't, then come and find me and I'll try and see what's happening. So you click your mouse in the little box down here, and you can type APL expressions. At the moment, you won't. The document that's on the memory stick tells you exactly what is available. At the moment, there isn't a huge amount that would be unexpected available, other than things like being able to do. Yeah, no, I've got the wrong keyboard installed on this machine. Other than being able to do multi-line expressions, and this one just illustrates that if you have unassigned values within parentheses, they're not echoed to the session. It's only the result of the entire thing that's echoed to the session. So you have a little play with the language features that are there. Unfortunately, there's nothing much that's new there. Most of it is stuff that you already know. But what we're intending to do over the next few months is every 3 to 6 months or so, we will be releasing a new version of the interpreter to anybody who's interested. So if you are interested, either see us later, give us your email addresses, and we'll make sure we mail them to you, or email us at aplsharp@dialog.com, and we'll send out updates as and when they're available. But we expect that to be at least every 3 to 6 months from this point going forward. Like I said, we've been a bit over-optimistic in the past, but we do think this is actually a realistic goal. And the final, we'll get to the right slide. There's my pointer. And the final example if PowerPoint wants to keep up with me, is just to show that we have in fact got this running on Windows 8 already on the Metro interface. This is exactly the same engine as is running on your Conference Edition memory stick in Silverlight. And you may notice that I'm typing on a touchscreen keyboard with APL characters down on the bottom. On a UK layout, of course. So that's all running on this device. If you'd like to have a look at that, or a look at Windows 8 in general, or that very application, then please come and see me in coffee breaks or whatever. I'd be glad to show you. So I think we've still got a couple of minutes for questions, so unless you're really thirsty, and any questions, otherwise feel free to go and get a coffee. Oh, we've got a question.
Integers, do you support 64-bit integers?
By default they're 32-bit integers, although we may introduce a syntax for declaring 64-bit integers.
At that time I always noticed that I need 64-bit integers when you go into
Yeah.
.NET.
Could you repeat the question?
Sorry. Yeah, the question was, are the integers 64-bit or 32-bit? And Ray was saying that often he finds when he's interoperating with various .NET things, he needs 64-bit integers. Now, when we're interoperating with the platforms, if we make a call and we've got a type that we know how to convert, so a 32-bit to 64-bit integer will do that automatically. If you want to declare types that, for example, a 64-bit integer that's too big to hold in a 32-bit integer, then we are likely to provide a syntax for that, but we haven't finished designing that part of it yet. So, any more? Oh, Carla's clapping. I think we'll finish there.